A new scientific era has opened with the exploration of space. Scientists are investigating the upper atmospheric regions of the Earth and other planets, the regions that lie between the surfaces of the worlds and the vast ocean of cosmic space. These are the shorelines that we are exploring. Typical is the research at the University of Colorado's Laboratory for Atmospheric and Space Physics. An ultraviolet spectrometer to measure invisible radiation from upper air molecules designed for flight in an Aerobee rocket as a scientific payload is launched in New Mexico. Along a vertical path, slowed by gravity to a peak, some 70 kilometers high. The instrument gathers its data. Measurements are transmitted by radio to recorders that preserve them. The rocket cannot survive the fallback as gravity pulls the rocket back down to crash. Other launches of the spectrometers over the Atlantic Ocean gather the same kind of data on ultraviolet sky glow. The researchers had to design their systems to receive the data accurately but quickly. It is important to have the data in a good form for analysis, a form suitable for use with a large computer. The data from the telemetry channel are not in such a form. A large computer cannot process them directly. To get the spectrographic data in a form a large computer can use, the researchers are using a small computer to transform them. The computer, a Digital Equipment Corporation model PDP-8, takes the signals from tape recordings of the radioed measurements. Using a special technique that ensures that the signals are correct in both time and amplitude, they are fed to the computer through an analog to digital converter. The PDP-8 transforms the data to be compatible with large computer systems and writes the results on magnetic tape for analysis at the university's computer center. The laboratory's research also involves it in the analysis of a far distant shoreline, the atmosphere of Mars. Using a different ultraviolet spectrometer designed expressly for the Mariner space probes, the laboratory personnel have conducted exhaustive calibration tests to make certain that the data received from the instrument are accurate, for they are transmitted millions of miles. The spectrometer has to operate in a space environment, measuring radiation not detectable at the bottom of our atmosphere. It is sealed in an environmental chamber for testing in an enclosure that more nearly duplicates the conditions of space. It is here that many of the calibration tests are conducted. Through electrical and data channel connections built into the test chamber, the spectrometer is powered and its results are sent to external instrumentation. It is through the external interfacing that the spectrometer receives its control signals. By these means, a researcher can make it duplicate much of its performance in space. If the PDP-8 computer were not in the system, the data for analysis would be in the form of graphical line plots. Evaluation of such plots is difficult, tedious, and time-consuming. Besides the inconvenience of their bulk, exacting care must be made when evaluating the myriad of spectral traces. It becomes a full-time job, forcing a member of the research staff from more innovative investigations to perform a necessary but exhausting task. And no matter how dedicated a worker might be, after hours of such work, the likelihood of human error is bound to increase. Therefore, to ensure maximum calibration accuracy, the laboratory personnel developed a method of using the PDP-8 computer to assist them. As outlined by Dr. Jeffrey Pierce, one of the developers of the Mariner ultraviolet calibration system, the spectrometer receives its light from a standard tungsten light source, which may be located inside the space chamber, but which is usually outside, shining through a special port. The light is broken into its components when it strikes a special surface that reflects its ultraviolet elements to the spectrometer. The spectrometer is connected to exact logical equivalents of its spacecraft circuitry, made of digital flip chip modules. Output is fed to an analog to digital converter, where with other inputs, the data are converted to the proper form to be processed by the PDP-8 computer. The PDP-8 is sufficiently powerful to perform the calibration analyses. Its results are printed out on a teletype, which is the computer's chief communication device. The results can also be displayed on a cathode ray tube screen for visual analysis, or they can be transferred to magnetic tape for analysis by a larger computer if desired. Usually this is not necessary, as the PDP-8 results are sufficiently detailed for almost all of the spectrometer calibration studies. The laboratory developed a special PDP-8 spectrometer calibration program for this purpose. Though much smaller than the giant university computer, the PDP-8 is a fully operational digital computer capable of reducing highly detailed or complex data to a manageable form. By having the small computer in the laboratory, it has been much easier to set the stage for the Mariner missions. Mariners 6 and 7 were launched toward Mars in 1969. In each, a spectrometer calibrated at the Laboratory for Atmospheric and Space Physics. Because of our present technology, the planets must be in a proper position with each other before a space probe can be launched. These relationships occur approximately 2 years apart. Even then, the planets are in favorable position for only a matter of days. The spacecraft orients itself so that the data it gathers will be transmitted back to Earth at encounter. In its own orbital plane, each Mariner swept out to the orbit of Mars, flashing by the planet before continuing deeper into interplanetary space, its mission done. Having sent back data from its flyby. And even as data were being analyzed from the 1969 Mariner shots, already calibration work was going forward for later Mariner ultraviolet spectrometers. Later missions include Mariners to orbit Mars. Equipment like the PDP-8 calibrated spectrometers will let researchers unlock centuries-old secrets of Mars, and PDP computers will help analyze the results. Later, research at other worlds, for Mars has but one shoreline to the sky.